Hello everyone! So this video is about motion, specifically distance and displacement. Now let us talk first about motion. So motion is all around. It is a change of an object position with respect to a reference point. So meaning there is a movement. So from reference point to its final destination. Now motion can be described in terms of the speed, velocity, acceleration, displacement, and distance. As what I have mentioned a while ago, that this video is about distance and displacement. So we're going to talk about it first, then followed by speed and the other quantities. Now, there are two kinds of quantities, the scalar and vector. Now, when we say scalar, it is expressed in terms of magnitude and unit. Now, what are these unit? These are grams, kilograms, kilometers, meters, mile, ml, liter, and so on. Magnitude meaning the number. For example, we have 1 kilometer. So that is scalar quantity. Next is the vector. When we say vector, it is expressed by the magnitude and unit with the direction. So direction, meaning the four fundamental directions are present, like east, west, north, and south. Then we can also use um, southeast, southwest, northeast, northwest, and so on. And so the only difference between the two is that when we say vector, there is a direction. Now let's go directly to distance and displacement. So when we say distance in our own dialect, distancia, meaning it is defined as the total length covered by an object from one point to another. For example, your mother asks you to buy something or to buy salt. Then, from your house to the store, that is already a distance. So it is a total length covered by an object from one point to another. And it is a scalar quantity which does not require direction. So in order for you to get the total distance, you are going to simply add all the distances regardless of the direction. Wherever you go, you just have to add all the distances. So here is the formula in finding the distance. So dt is equal to d1 plus d2 plus d3. d1, d2, and d3 meaning you covered three distances. For example, you walk from your house to the store, that is distance 1 already. From the store to your friend's house, that is distance 2. Then from your friend's house to another house of your friend, that is considered as distance 3. Now if you're going to ask your total distance traveled, then you're going to add all the distances that all the distances. Okay, so let us use this example in your module, calculating for distance. The problem is, a car travels 100 meters and continues to another 250 meters. What is the total distance traveled by the car? So we're going to write the given, which is d1 is equal to 100 meters, d2 which is 250 meters. Then what is asked, it is the total distance traveled by the car. Now the formula in finding or calculating distance is you are going to add d1 and d2. So for the solution, you're going to have 100 meters plus 250 meters is equal to 350 meters. Please do not forget to write the unit. Let us have another example of distance. If A turtle travels 100 meters going to mango tree and another and travels for another 50 meters to gumamela plant and finally travels 150 meters to a guava tree. What is the total distance of the turtle? Now, take note that for distance 1 we have 100 meters, distance 2 is 50 meters, then distance 3 is 150 meters. Now, using the formula, total distance is equal to distance 1 plus distance 2 plus distance 3. You're going to substitute the values. So we have 100 meters plus 50 meters plus 150 meters for a total of 300 meters, meaning the total distance traveled by the turtle is 300 meters. Now take note that for distance, all you have to do is to add all the distances. Now let us talk about the displacement, which is a vector counterpart of distance. What do you mean by vector counterpart? Meaning, for displacement, there is a direction since it is a vector quantity. Now, it is the measure of an object's change in position relative to a reference point. So, there is a change of position. Now, displacement can be expressed as change in position. So, this triangle can be read as change. X is the position. So meaning this is change in position is equal to final position minus initial position, where X final is our final position of an object, X initial is the initial position of an object, and we have this, the displacement or the change in position. So for example, we have Anna walks 35 meters east from her house and continues for another 55 meters. What is her displacement? So take note, in answering problem like this, you're going to write the given. So we have the initial, which is 35 meters. Then we have the final position, which is 55 meters. Then you're going to compute the change in position or the displacement. So for the formula, we have displacement is equal to final position minus the initial position. You simply substitute the values. So we have 55 meters east minus 35 meters east, meaning you are going to subtract. Now the answer is 20 meters east. Please do not forget to write the unit because it is important for vectors. And we have another example here. So calculating for distance and displacement. So problem, a turtle travels 100 meters north from a nara tree and continues to another 150 meters to coconut tree in the same direction. What is the total distance traveled by the turtle and its displacement? So we have the given 100 meters and 150 meters. You're asked to compute the total distance and the displacement. So let us compute first the total distance. So we have the given 100 meters and 150 meters. So take note, for distance, all you have to do is to add. So the formula, total distance is equal to distance 1 plus distance 2. So you're going to substitute 100 meters plus 150 meters is equal to 2 150 meters. So that is the total distance traveled by the turtle. Now for letter B, we have the displacement. So the given still are 100 meters north, which is the initial position, and 150 meters north, the final position. Take note, please don't be confused with the final and the initial. So, for the formula, we have change in position, or the displacement, is equal to final position minus the initial position. Then, substitute 150 meters north minus 100 meters north is equal to 50 meters north. So that's that's the displacement of the turtle. Okay, to sum up distance and displacement, for distance, all you have to do is to add all the distances regardless of the direction. Now, for displacement, you're going to subtract the final position and the initial position, and make sure to write the direction. I just have to clarify that for displacement, you don't have to write all the direction, but what is the given direction in the problem. If the given direction is north in the problem, so you're going to write north. I just have to clarify it.